Okay, so this is part 3 of what is available. So I was talking about what all things are available. So there are things available to enhance this ID itself. So there is a graphs. I show you one way of defining a component. There is a really nice, sexier way of defining a component. What you do it is, okay, so there are different modules available, canvas module. So within the canvas module, so you define a canvas module, you can go and then use it in programming. This is basically a SVG canvas where you can do drawing, and then it automatically expands and minimizes, resizes automatically, and then you can save it and then build your own dashboard, programmatic dashboard, and save it. I have a lot of programmatic dashboard that were built like that. uh, let's go and take a look at, yeah, SQL output mapping is used basically. You can do select, I think, a comma b comma c from table t. I forgot how it is used. Basically, you can define a SQL mapping, define a SQL query that is looking up. So there are two kinds of SQL mapping: dynamic SQL mapping and non-dynamic. In dynamic, you give a query, it will go and run the query in database, find out the object model, and build the table here. Similarly, it will can do it a SQL output mapping. So, and then you can use that mapping to build SQL objects to load data from tables, put the data in tables. You can use it in process and stuff like that, right? So yeah, for SQL specific, it's there. And the idea behind that was I used to build my whole pipelines in there, and I define SQL mapping at the end object, and that object would be custom saved on there. And by the way, it used to hold work with on iPad. So this application was actually designed on iPad. So I used to code, in my corners of my room. Uh, so let's go and take a look at simple static module. I don't know what that is. Let's see. Forgot it. Simple static module is, I think, headless module. Uh, we are looking for anonymous script module. Is you go here, you can define a code, and then you define here in the code editor, and then what happens is that code will go in there, and then there is a template defined. You define in that template, it will create, automatically convert it into ports, input output. So you can in fact define your Java object here, and that Java object will become port. If you want to take a look at example, let me show an example. Design dot open design. All right, so it's very easy. So let's say Chrome 2. Go here. So there is a language that is defined for here. You go here. So if you see here, right, you can define, this is the way you tell what is the port in region, and then you can also define types. So what it will do is automatically detect that you have two values that are parameterized and you want to do. So this is basically use what is we call as parametric designs. So you can look at the parametric design and do it. And there are certain parametric designs that actually convert the parametric design. So what that means is that's a order to. So you will define this, you will define one more, one more, one more, and then you will define a component that will be here. What that will do it is, when the graph is compiling, it will take all the components, give it to that level 2 component before compilation and after compilation. So they can modify it. So I can define this graph, and between this I can define a node that will take whatever input is here and do it. That is was just an experiment in how we can define it. But let's go. Okay, so I think static module was the one. Yeah, so static module uses basically, so in the static module was used to define really beautiful components yourself. So you can define your component that can do certain things, and then submit the test model. And then I think it has a form text field. Let's say name is s value ss. Okay, I defined done. So this is now available as a module, right? And I can again save it and then available it. What we can do it is, I can portify the module, input and output, and then I can tell you this object is used as input or output. So I can say portify module. I go here, it will convert this into a uh, into basically available as a module. And what that will do it is, uh, I don't have to worry about building. So I can build a object how it should work, define the code in the source code, and that source code actually, I think there is a syntax for it. You define it, and that script will be available to the backend for the code compiler to, or handling the inputs in there. So there is um, a lot of code written in the backend, how it compiles and how you can build your mappers, right? But that's basically again, so this I can do it, and then I can define a, let's say, and then I can use it for Java. I'm just dropping a, let's take an example of anything, doesn't matter, right? That's not sensible. That's sorry, we have to look at the generated. Let's say I drop here, and then oh, that's not there. That's yeah. For example, but I take this, I can go and connect ports. Yeah, and then let's say if there is by mistake some port is wrongly connected, I can always go and change it, right? And then I can connect to anything to anywhere. So this doesn't have to connect here. This has to connect here. Then um, there are a lot of things available with the connections. I can go and connection and then reverse it. I can connect connection on the server. I can connect connection. What does connection on the server means? It will create a stream that allows you to take this object and then output this type. Um, Again, that is there. I'm forgetting one really cool feature. Another one. Design. New design. What else you can do? Oh yeah. So how does the visual tagging and annotations work? So visual tagging and annotation works like this. I think I might have example of. So I will show you, right? For example, I have a machine like this. I defined its control code and define its source code, right? So I can define the whole module in here that basically uses server, and then that basically I save it, and then it becomes an application. I think most of the companies won't allow you to do that anymore because this is considered a security hole because it could do SQL injection. But this is application I am building for my use. It's a similar thing I can go to Eclipse and do in my machine. Right? It's not supposed to be run anywhere else, and we always run in local host context. So there is really no risk if you ask me. But yeah, somebody could inject a bad code can make you do bad thing. But that would happen if that means somebody had got access to your machine, and that means can do anything. Let's take an example of, yeah, it has a shortcut. So shortcuts are basically, a way to do automation. So I could say shortcut is test expansion in ext and shortcut works on application. So what it means is, I use shortcuts, a lot of shortcuts, and the way the shortcuts works is I will do here, and I think there is a mapper compile shortcut, something is there somewhere, or compile deploy graph somewhere is there. What it will do is deploy this shortcut anywhere I go. I type that test and it will basically expand it to ext if the application on top of notepad or outlook, and then that's how it would do. Or I could run a macro or a code, right? That could do things. I use it for automation on my machine. um, the other thing is animations are used for building animation. Basically see how you can build the animation. So the way animations are used is you can keep adding animations, define the timeline. Then there was a animation compiler. That was a plugin. What it would do is it will allow you to do time-based processing of things, and then a lot more stuff that basically, for example, like music compositions, you would have seen these animation objects, right? This is similarly, it would define these objects, and it was used for building animations, not just animations. For example, I want to do this and this and this, and it was also used in another way. I could define the animations as a tag, And then I has a event browser that would browse the event. I could add the animations as a tags, and that would allow me within all the events that are happening within that animation region to be tagged in a same way. I don't think I'm explaining it well. So let's take a look at something that was pretty niche. Forgetting visualization. I think I went over, and those are templated visualizations. Local image processing. These are yeah, these are basically used for yeah. So it has a built-in support because I use the same ID and same components to do my in my workshop. So it has a lot of support to uh, for CNC work, basically specifically hole and paths, and then you can take SVG drawing and then give it to machine, and machine will basically run it, or any robotic use for that matter. But I wanted to show you how I use it for AI and AI tagging. So I think one of the examples was DRO. All right. So in the DRO, I have built a specific tagging for UI. I think there was an example in design library for train DRO. I think it would be train DRO3. So this is how I train it. Basically, I take the image, which is uh, so the way image loading is work is here. I define an image tag. I define what is the size of that image, and it can get from the camera too. So all you have to do is define with a real-time camera. Then I have these taggings available. I think you have to zoom it. So this basically is telling how this this is the sixth value of this there, and then there is a 7 segment model in the backend. Then all I have to do is point the camera here, and if my camera changes, location changes in my workshop, I will have to change it. But then it will convert the 7 segment LED into uh, a text value, and that was used by, or a numeric value, and was used in processing. For example, mapper compile. I think there is a compiler here that does it. I forgot what is it. It is, I think, I forgot what that mapper is, but I used to do that training here. I have to see what is that mapper. So what basically do is it will take this, compile it and introduce it. And then when I run a process, what that process would do it is basically would live look at this changing, and I'm moving my machine. It will allow me to stop and do stuff. Other example of visual tagging is like this. I think I have it here. Yeah, Chrome to annotation. So these are the annotations that I have defined. For example, I have defined this annotation to be a button or anything. So I can take an image. So this is the image of my desktop. I can take that image, then I can annotate it. And once I have done all the annotations, these annotations are available in. Uh, so this is how I do. I take an image of my application or something that I want to do, annotate it. To do annotation is very simple. I go here, I create a new face shape, and I say annotation 1, right? And then I will annotate this area and say now this is my annotation available. Let's say I do it here, right? And then I would say this is basically should be here, right? So this is annotation define. I would say save design. Now this annotation is available in my, let's say, duplicate it, right? So if I open here design, open design, and let's say I have uh, right. So I have defined a lot of droppables, which basically can take that annotated object, and that annotated object name is here, right? So I define it, which is annotation to do. So here, this design, this is was the annotation. That's basically this Chrome 2 design is the annotation, contains all the annotations. So I tell it, take the annotations from this page, and those annotation names now are available, shape 1, shape 2, shape 3. Then I can go and say do something. So basically what I'm saying is click on a region where shape 1 is defined, and this basically is corresponding with my screen. By the way, this is screen, right? the DRO annotation was with the physical object, right? So there are different compilers based on what we need to do. So this is a compiler for my physical world annotation, and this is a compiler for my desktop annotation. So this is a desktop image, which is basically, and these are the pixel values. So it's saying on my desktop, this region, this pixel region is defined by region 1, this by 2, 3, 4, and this can be used for robotic process automation, visual testing of applications, building tons of other stuff, right? And then all I go, then I'm doing this graph, which I'm saying is use these annotations, sleep for 2 seconds, then go to region 1 and click, click on region. So click on region 1. This is the region 1. So over here you see region 1. So on this actual screen, it would be somewhere here, it would click. Then I would say wait for 2 seconds, move mouse to shape 2. Shape 2 is here, which would be somewhere here. And then I'm telling on the shape to send keys to the region 3. So region 3 is, I think, this region or this region. I think this is the region 3. Um, Window properties. Go here. Then, okay, sorry, it will not show here. I will have to window. So I have the component. So if I'm confused which region it is, so therefore regions, there is a lot of things available. So let's say, I think region 3, I want to region 3 show. So this is the region 3. Okay. And these are, so yeah, so it will click here. Then I just go here, mapper, design. Let's say I will run. Then the way it will work is I will say mapper, compile, run automation. So it basically clicked there. And then I think the third somewhere here it should type. So that's my robotic process automation. Yeah, I think that screen was not selected, so it typed somewhere else. I couldn't bring it up, right? But this is how there, and there is a lot of processes available for robotic process automation, which is, wait for image, check image. These are available. Whether contains image, so I could say, wait for this region to be have this value, change this value, that value, and then I have a API plugin available where I can call Google service to say, go to Google, see what this image looks like, okay, and then attribution and all I can do. So that's available as a graph here. So what I do is I go and annotate my desktop. Then I go here, say run the graph. All those annotations are available. And then I run my RPA graph. And then I can also do a validation graph. A validation graph would be, you take a screenshot, or, once you run this graph, after that I could add if image contains this, then validate this test case, or image contains that, do that. And then, there are hundreds of functions available to do that. I basically use it for very simple thing. I use it for DRO, and sometimes I want to extract information from web pages, right? So I could say go to this web page, extract this information, turn this information this way, and use it. Yeah, and then there are other mappers that I think I didn't discuss. There are hierarchical mappers. There are other mappers available. Yeah, I think that covers a lot of stuff. We can go into how it compiles and runs and loads later. Um, what this basically show graph element, this is debugging. So yeah, there is a lot of debugging info available. BAM doesn't works because BAM was something else. There is a undo redo, there is a checkpoint, there is a reload components, there is a, for moving the graph, there is copy paste selection available. Um, yeah, and then there is one more thing available. So you can define the objects and they become part of a region. I think the way regions work is, so regions works like a swim lane. So I can define a region, I can also define layer, then I can move the objects between layer, then I can do layered processing. So it supports both layers, so I can create a layer, and then this is my layer, right? So anything that comes in here, I think layer has its own, uh, somewhere there is a layer related objects where I can freehand. Yeah, I think it shows here. Window components. I'll see the layer. And then I can do show layer. Um, I forgot what how the layer is done. Yeah, but layers would show. I think freehand. Let me delete it. I think I forgot freehand create layer. Zero. Mm, yeah, I will come to layer. You can define nodes also, and then nodes are visible here. Then there is something called as group. You can group the objects into a certain group. Then you can hide a group, show a group. So I think you can create a freehand create group, create region is physically available object. You cannot move a region once it's created is there. Then there are avoidance regions, avoidance layers that are used for certain types of graph. Group selection, align horizontally, grid pattern. Yeah, aligning is for aligning, basically text mapping. Oh, I think there is somewhere freehand layer. So I forgot how the layers were actually work. So there is a layer menu somewhere here. Layer window, the window properties. Sorry, yeah. So this is a region. It doesn't have any object, but let's say the the regions are basically used by streams and processing and for robotics needs. So for example, let's say create a stream. I added a stream, some random stream. If I move the stream here and look here, then it will say, it has the, I think regions, sorry, doesn't define it. The layers define it. I'm not sure uh, how to see the layer. Yeah, advanced is used in a different way. Um, so I forgot how the advanced is used. Advanced is, so yeah, when you define a node, let's say define this node, right? Um, there is a way you can modify node. I forgot. So you add a node, then on the node you define the annotations. So let's say you define the annotation on the node, and then it will become scatter together kind of things. Then you can define other tags. So there are tags available for the nodes that nodes use. And then I think I double click or something, shift click, then it will show all the annotations. So there is some niche available here. I don't see it. How that works, right? I don't remember design. But the layers should work. I don't know how the layer is. layers work. Um, but basically layers allow you to layer the things, and you can turn on and turn off layer. Oh, I think the show and hide layer works in a different way. So if I create a layer, freehand create layer. So I created this layer, right? So I think there is some error, but the layers they work in a. I can see the layer, and then I can see. You know what? I think I know. Redraw. So if I create the way layer works is layers are used to hide certain types of objects in mapping and other diagrams. So I think that's a design dot open design. I think this is how it works. Let's say I do here freehand create layer. I think I would create a layer here, correct? And then yeah, so you now see the layer, because the layer if that has no object it doesn't shows up. So it's basically showing I have created layers is basically I remember now is a logical binding, and it is used in the backend to do certain stuff with the layers. So now I have these two objects in this layer, right? You can see these are wrapped by this. That I can create another layer, freehand create layer, that I would say these four are there, right? And then if I go here and say show me the layer 2, right? So that is showing these four components are in that, these are five there. So the way layers would work is when the components are all executed in that layer, you can raise the alarm, or you can say the layer, and then you can also do it in uh, I think you hide all the components in layer, you disable the layer, enable the layer, and then anything, if you disable it, anything that falls in that layer is not drawn and is hidden, and if you want to enable that, enables the layer. And there was a use for this, basically the way layers were used is if you used uh, camel graphs, or if you use node processor streaming graphs, or if you define graphs, let's say you define graph, define a stream demo app, right? So you could define a layer and would say this is layer 2, right? So now we know this is in layer 2. When I see this is in layer 2, all I could say is disable this layer, so that layer will not be visible. Alright, all the connections are available, so you see what is the connection in that layer, but otherwise the layer will not be available. And there is a way to say turn off the connection, don't show the connection if the layer is not visible, and that's how it's there. So layers are basically logical binding of objects, so it's created from the objects. Region is a physical attribute, so if I say freehand create a region, right, that's it, this is free and created a region. So we look at that region properties, it's telling you these are two stream nodes in one, and then I can turn off physically there if I want to turn off, and regions cannot be moved. So let's say if I want to add one more item in this region, I could add here. If I look at this region, if I say redraw and then go here, and I think there is a freehand update region. I think it's somewhere update region is there, freehand region dot update regions. So now what it does is if I look at the region, it will have this object as well in there. So that is basically after you have, that is done for physical mapping. So I could define processor, create the regions, and if that processor is in that region, I could say disable it. Right, versus of logical binding, and then I say I could put the regions in there. You can really do a complex. Regions were basically used to define a combined graph. So I could define the way it was used is I could define a big complex stream that will be running on 5 machines. I could define a physical region for this machine, second machine, third machine, fourth machine, And then I could say this region belongs to this machine, and then when I compile it, every machine has its own region. So anything that within that region is also running on that machine. That's how the regions were used. And then I can change the physical layout and deploy the same graph simultaneously on multiple machines, but only thing that applies to that region will run on that machine. That's how the regions work. Layers are only used for visual analysis, and in certain cases, I think only two mappers use on the back end, two or three mappers. That's what I remember. Yeah, that's it. I don't know. There is a, yeah, there are certain utilities that work only on designs. So if I look at the design, I don't know how many map will work. So this is the minimum spanning tree of there. So that works with design. And there are other uh, there. This is used for large mapping analysis. Minimum spanning tree will tell me um, when I was, so there is a way to reverse engineer the code and generate this diagrams, mapping diagrams. So spanning tree was used to analyze if any mapping we are executing again, and what are the minimum components that I need to deploy, so I can reuse that component instead of deploying a heavy component. So that's how the minimum spanning tree was used. I was using it. Yeah, that's it. Recent action tells you what all recent actions are there. Probably one day will show. Yeah. And then, everything is pretty niche. So if you say design, new design shape, new face shape, let's say W. You can move these points around. You can convert this shape to a smooth curve. I think. I forgot how the point selector works, but there is a way to smoothen the shape. There is a way to add points. Um, there are a lot of things that you can do within there, right? And shapes are multifaceted shapes. That's it. Inspector is there. Inspector is a window when design, new profile, open graph here. So the way inspector was running a file. Um, the way inspector was used is, if I have this stream deployed, I could drop a inspector and then inspector will start showing the logging values. So I could take the inspector here, inspect this object in the streams right there. So what it would do is it would just make a API call and get it. And I could open browser multiple tabs and then start inspecting the streams right in the UI. So that way I would observe it. So for example, if I started a file copy job, I would just drop here and just sit and watch it. I don't have to go to logs or anything. There was another thing that is there. So there are a lot of things that are built. So I could see show check graph status. So it would tell us, how the things are working on the server with failures. So it is saying, this connection is not deployed, stream is not running, the node is not healthy, event is healthy because event is available and everything is working fine. So I can look at a graph health entire year. What we can do it is, there is a graph. This is a graph that is design graph. I can build a monitoring graph, save the design, and then I go to annotations. I think in the widgets, I can draw a flat green LED, flat red LED that would wait on something on the heartbeat from the server, and then would do something. I forgot. So those annotations will start seeming based on there. And right now I'm not receiving heartbeat event, so I think the way start heartbeat event is hmm, start stream. Yeah, so I start streamer. Now streamer will start listening to these server events and will check for the events and then basically change the graph. So now this graph, because I have dropped these annotations that tells us things, what it is doing is it will listen to the server for any events. Once the event is received, it will basically show the color and status. So for example, if I get a event that this got a message, then this will, that light will turn on. So I could design my visualization of the graph right from here and save it. Like remember we saw the show graph, basically check graph status. We saw those annotations. Similarly, we can see those annotations. Those start showing up here. Yeah. There's are tons of features that are built in here. There are only two graph versions available. One is this and the one is latest. Yeah, so that's there. Adding an object type is very simple. You just have to go in JavaScript, add a object type, and that object type, that simple object type, you have to define certain methods and is available. As I've shown you, you can draw shape, right? Any custom shape. Shape is an object type available, right? And then you can even connect these shapes and then you can assign shape property. Then you can write a graph to compile these shapes, right? Or use shapes as a input output. You can do tons of stuff. So basically you can take anything and convert it. And I don't have to even code anything in the backend. Everything can be done here. But certain times I go in backend to build the support. Yeah, and the backend, the way it generates the code from these is very niche. Uh, and there is a particular way of designing it. So there is a compiler. So the compiler hierarchy is there where one compiler which generates a certain type. The compiler uses a template. So you define templates, how the code is generated, and that template is taken care. That template basically is a class that is derived from a class that has its own hierarchy and helper objects that it uses. Then there is a processing library also that you can define here that can use that hierarchy object. Those are the ways that you can define it. Yeah, that's it.